Hey everyone, let's do the lesson 16 practice. I'm going to do it online this time rather than in the book. So on this first screen, the warm-up, you could like sort of plug in or substitute the values in the boxes for x and then see whether or not the inequality is true. So for example, if I wanted to test this very first one where x equals negative 3.9, well then when I substitute that in for x, I have to think of this double negative situation that's happening here because I have negative x, and so that would be negative 3.9 because x is negative 3.9. So there's like a double negative thing happening here. Plus 6 has to be greater than or equal to 10. Well, the negative of negative 3.9, or in other words, the opposite of the opposite of 3.9, negative and opposite essentially mean the same thing in this context. Well, then that's just going to be 3.9 plus 6 is greater than or equal to 10, which means 9.9 is greater than or equal to 10. That's not a true inequality. 9.9 is not greater than or equal to 10. So I would not check this box. I personally think that's sort of a slow and just kind of clunky way to do this question. And so for me, I would prefer to solve the inequality and just get it to where it says x is greater than or less than to something. So it's really clear and easy to see. And in order to do that, it looks like it has this one selected. I don't want it selected. No, okay. In order to do that, you have to remember sort of a weird fact about inequalities that you should have learned in class today, depending on how class goes. I'm recording this like well in advance. Let's get there first, and then I'll remind you about it. So we have this inequality, negative x plus 6 is greater than or equal to 10. So I want to subtract 6 from both sides in order to just get negative x by itself. You've probably already seen it. I have the answers here on the bottom this whole time. Hopefully you didn't just click the answers and move on. So what this is negative x needs to be greater than, oops, no. We're only like 2 minutes into this video and I'm already making mistakes. Negative x needs to be greater than or equal to 4. Well, we can get that x to be its positive version, which doesn't necessarily represent a positive number. It's just positive x. It's kind of weird to think of it that way. By multiplying it by negative 1. But that means I have to multiply over here by negative 1. And what happens when you do this with an inequality, when you multiply or divide both sides by a negative number, this sign that used to say greater than or equal to needs to switch and become less than or equal to. And I'm pretty sure we talked about that in class earlier today, whether you have me or Mr. Wong. And so hopefully that just sets up a light bulb and you're like, oh yeah, I remember they showed us that. But it's pretty weird when you first learn it. So x needs to be less than or equal to negative 4 in order for this inequality to be true. And now it's kind of easy to go through and pick the right answers, right? And they're already down here at the bottom for you, but negative 4.01 works, negative 4 works, and negative 7 works. So all the ones that are more negative than negative 4, or exactly negative 4. All right, cool. I don't want these answers on the screen. All right, let's move on. All right, so the library is having a party for any student who read at least 25 books over the summer. That's a lot of books to read over the summer, dang. Match each inequality with either a story or a number line graph. Okay, so the inequalities are supposed to match with the other things. It says match an inequality with either a graph or a story. So I'm going to put the inequalities across the top. Okay, so I guess it's probably easier to look at the stories or the lines and then match those to the inequalities. So I'm going to look at this one here. I see that the 25, the circle over it is not colored in, or what we call an open circle. So that means whatever inequality this goes with is not going to have the little equal bar under its symbol, right? It's going to be, these are all the values that are greater than 25, but not 25 itself, because it's not colored in. So I would be looking for an inequality that says something like x is greater than 25. Do we have that one? Oh yeah, it's like right above where I'm at. Right here. Okay, clear my screen. Let's do the other number line one. So this one, you should see that it does have the circle over 25 is colored in, or what a mathematician would call it, it's closed, so the circle is closed. And then all the values less than 25 are the ones shaded. And so this one, I'd be looking for something that says x needs to be less than or equal to 25. Do we have that? Yeah, looks like it's right here. Okay, just 2 more to go. Let's try this one. It's either going to be x is greater than or equal to 25, or x is less than 25. That should be easy to figure out, right? Like one's going to be more and one's going to be less. So this one says Prisha read X books over the summer, but was not invited to the party. Okay, so Prisha didn't get invited to the party. That tells me she did not read at least 25 books, right? Because that's what this whole thing is about. Or in other words, she read, I'm assuming that's a girl's name, they read fewer than 25 books. So I think that's going to be this one over here. X is less than 25. And so by process of elimination, this one's probably going over here, but we should double check because sometimes they like to throw oddballs at us. Ricardo read X books and was invited to the party. So that means Ricardo must have read at least 25, right? 25 or more. And that's what this inequality says. So I think we got it. All right. Next, it says, select all of the values of X that make the inequality 100 minus 3x is greater than or equal to negative 50 true. You can try substituting all these different values into the inequality for x and then doing the math and see if they work out. I personally think that's the really slow and harder way to do this question. I think you got to solve the inequality first, and then it becomes a lot easier to see which ones are solutions and which ones aren't. So I'm just going to solve it. Now remember, solving inequalities is exactly the same as solving equations, except you have to remember that one weird little fact that I talked about at the beginning of this video. If you multiply or divide both sides of your inequality by a negative number, the sign, the less than or equal sign, has to go, or you got to switch that around. And I think we're going to wind up doing that in this one. And I think we're going to wind up doing that because I see this -3 right in front of my x, right? I'm not reading this as 100 minus 3x. I'm reading this as 100 plus -3x. And the fact that there's that -3 in front of my x makes me feel like I'm probably going to divide by a -3 to solve this thing. And that's going to make that inequality sign flip around. So let's do it. 100 plus -3x, I'm just choosing to rewrite it this way because I like seeing it that way sometimes, is greater than or equal to -50. I'm going to subtract this 100 off of both sides to get that 100 taken care of. And so I get -3x is greater than or equal to, what I have here is -50, and then I'm subtracting 100 more or adding another -100. And so what I get is -150. And now I want to get rid of this -3 that's multiplying my x. So I have to divide both sides by -3. And that's going to make my inequality sign do the. So we got x is now less than or equal to -50. Oh, wait, no, not -50 because I got a negative divided by a negative here. So that should be a +50. All right, so x needs to be less than or equal to 50. Now it's kind of easy to pick the solutions, right? 0 is less than or equal to 50. I'm going to select that. 50 is less than or equal to 50. It counts because it's equal. -50 is less than or equal to 50. 49.9 is less than or equal to 50. 50.1, however, is not. So I think these are the ones I'm going to select. Let me double check my answers just to make sure I didn't oof something up. 0, 50, negative 50. Yeah, looks like I got it. Cool. All right, so in order to solve the inequality, 100 minus 3x is greater than or equal to negative 50, the one we just did on the previous screen. Michaela solves the equation 100 minus 3x equals negative 50 and gets x equals 50. What is the solution to the inequality? Well, we already did it, right? We did it on the previous screen. We got x is less than or equal to 50. And so I think this is Desmos trying to get at this idea. Well, I would think maybe they're trying to get at two things. One, sometimes students accidentally forget they're doing an inequality and they put an equal sign there and they just sort of go into equation mode because we do equations for so long. And B, they're trying to see if you know that like the answer is not going to be x is greater than or equal to negative 50. They want you to look at it and think, oh, they had to divide by a negative 3 somewhere in there. And so that inequality sign said, whoop, and now it's x is less than or equal to negative 50. I think that's what they're kind of quizzing you on here. So let me show you something. If you're on a Mac, you can hit the Alt Option button and then the key that has the lesson sign, which is like on above the comma right next to your M. And when you do it, you get the less than or equal sign. Now, if you're not on a Mac, another way you can do that is you can make the less than sign, right? The one that's just above the comma, but you're like, wait, but I need my equal bar because it's supposed to be less than or equal to. Now, if you don't hit space or anything and you put an equal sign next, Desmos knows what you're trying to do and they give you a less than or equal sign. And so I think that's what our solution here is that x needs to be less than or equal to 50. And so explain what the solution to the inequality means. In order for the inequality to be true, right? That's what we're always looking for with solutions, right? When you solve an equation and get a solution, that number makes the equation true. It's the same thing for inequalities. You want numbers that make that inequality we started with a true statement. And so in this case, in order for the inequality to be true, x must represent any number less than 50, or in this case, equal to 50 because it has the equal bar, right? So we should specify that, or equal to 50, or exactly 50, something like that. All right, so now we're gonna do some spiraling stuff. They like to throw in old stuff in these assignments. We got some proportional relationship ratio stuff here. Alma makes 5 cups of her favorite shade of purple paint by mixing 3 cups of blue, 1.5 of red, and 1/2 of white. Alma has 2 cups of white paint. Assuming she has enough red paint and blue paint, how much purple paint can Alma make? Okay. So lots of different ways you can go about this one. The way I would do it is I would look for my constant of proportionality, aka my K. Geez, you remember that stuff from way back in October, September, whenever we were doing that? Remember, that's going to be y divided by x. And y is, so if we want to make this into like a table here, let's say I have my, like I want to make my new paint here. Let's think of it this way. It's just been a while since I did this stuff. So I'm like, how do I explain this? So like this new unknown amount of paint. My pen's not writing very well right now for some reason. Like it's being weird and laggy. So, and then this is the original recipe that we've been told, right? Okay, so for, let's see here. For blue, you use 3. Right, this is blue. For red, you use 1.5. That's all right like that. I could have wrote 1.5, but whatever. And then for white, you use 0.5. And then the only thing we know about the new unknown recipe, or the amount that she's trying to make, whatever you want to call it, is that she has 2 cups of white. Okay, and so we can get a constant of proportionality if like these are our y values and these are our x values. We can do y divided by x. And so that's going to be 2 divided by 1/2. So this is one way to get it. And you would do this by keep, change, flip. You should kind of remember that. Oops. So I want to do 2 over 1. I'm going to keep. I'm going to change from division to multiplication. And I'm going to flip that 1/2 to 2 over 1. And I get 4 over 1. So in other words, my k equals 4. Another way you could have figured that out is if you just know that, oh, 1/2 goes into 2 4 times, like 1/2, 1, 1.5, 2. If you could have just figured out that it was 4 that way, that was another way to do it. That's supposed to be a 4, but my pen's being really terrible right now for some reason. All right, so now just take the other 2 colors of paint and just multiply how much she has by 4, and you get the right amount. So 1.5 times 4, that's 6. 3 times 4, it's 12. So, and so now they want to know how much total paint can she make though, right? So you got to add all this up because she's putting this much of each color into the bucket or whatever. And so she's going to wind up with what? 12 plus 6 is 18 plus 2 is 20. So 20 cups of paint. Now that I think about it, you didn't even really have to do all that, right? As soon as you figured out that she had 4 times as much white paint, you should have been able to figure out proportionally that she was going to wind up with a 4 times bigger amount of purple paint instead of 4 times 5. If I'd have stopped and thought about it, you didn't even have to do some of that work I did there in the table, but whatevs. Maybe, I wonder if some of this work is going to be useful on the next screen because we figured out that it's 12 blue, 6 red, 2 white. I'm going to keep this on the screen when I go on to the next page because watch some of this be what they ask next time. How much blue paint and red paint? Yep, so that's exactly, so all right, so we figured that already. So we know it's gonna be 12 blue and how much, 6 red. Brain freeze there for a second. Good, I'm glad I kept that on the screen so I don't have to do that work again. All right, now screen 7, the Explore. So they want us to find a value that makes the left one true, a value that makes the right one true, and a value that works for both inequalities. I'm going to skip the idea of trying to find one that works for the left one and one that works for the right one, because if I find a value that works for both inequalities, I can just put that in all 3 boxes, right? Because it works for everything. So I'm just going to get straight to that. I'm going to solve both of these inequalities, and then it should be relatively easy to figure out a value that works for both. So I'll solve the left one over here in green. We got, let me draw. 5 minus 2x is less than or equal to -3. I'm going to subtract 5 from both sides. And I get -2x. Notice I did not lose that minus sign that was in front of the 2x. It's a -2x is less than or equal to -3 minus 5 is -8. I'm going to wind up dividing both sides of this by -2, and that's going to make my inequality sign go whoop. So I get x is greater than or equal to 4. Okay, so I'll just keep that in mind. I'm going to solve the other one while keeping in mind that, okay, in that first one, x has to be greater than or equal to 4. The other one, we got, come here. Why is this being so annoying? Okay, my pen thing is really giving me a hard time right now. Just copying the problem. Actually, I don't like to call equations and inequalities problems. They're not problems, they're just statements. They can either be true or false. All right, so I'm gonna start by dividing both sides of this inequality by -3, because that's gonna cancel this factor of -3 right here, goes away. But I have to divide the other side by -3 as well. And so I have -5 plus x is now less than or equal to, because I divided both sides by a negative, so less than or equal to -1. 3 divided by -3 is -1. Now I'm going to add 5 to both sides, right, to cancel out with this -5 that I have right here in the front. And I get x is less than or equal to +4. Look at that. They did that on purpose. And so the two inequalities solve so that one of them is equivalent to this. This inequality right here is equivalent to x is greater than or equal to 4, or in other words, has all the same solutions. And then the one on the right is equivalent to this. X is less than or equal to -4, so it has all the same solutions. The only number that works for both of them is just 4. But that means I can be lazy, and I can put a 4 over here, and I can put a 4 here, and I can put a 4 here. Or if you just want to show that you understand the inequalities a little bit better, you can say, okay, this one is x is greater than or equal to 4, so I'll put a 5 here. And this one is x is less than or equal to 4, so I'll put a 3 in this one, just for whatever. All right, that's it. There you go. See ya.